Welcome to the channel, everyone. If you didn't know, this is a lunar lander called Blue Ghost 1. It is currently orbiting the moon, preparing for its landing. The landing attempt will be this Sunday, which is March 2nd at 2 a.m. I will coincidentally be going live to cover the landing, so please join me for that live viewing if you so choose. I know it's late, but I think it's worth it. This video was shot on the 24th, so a couple days ago, but it has been taking amazing, as you can see, video and pictures along the way. Some of the Earth as well, so let's check some of those out here. This is one of my favorites here. The reflection off the solar panels can be seen below. Great clear picture of the Earth. Just beautiful. Looks incredibly flat to me. You can see the dome here. Yeah, I'm just kidding. Don't be one of those idiots. Here's another nice shot. But where are the stars? Seriously, if you're asking yourself that question, you may be a flat earther. If you're actually curious why there's no stars, it's because of the exposure of the camera. The camera can't pick up the dim stars next to such a bright object. To do that, you'd have to overexpose the Earth, and it would probably look like the sun. It would just be a big bright ball of light. And maybe then you pick up some stars. It's the same thing that happens on Earth if you go to try to take a picture of a full moon. You're not going to get any pictures of stars next to the moon. It's not going to happen. Here's another blue marble type photo. Great stuff. And while this thing's playing in the background here, I'm going to read for you some of the instrumentation that's going to be on this thing. There's a whole bunch of experiments that they're going to be performing while they're attempting to land at the North Pole, or close to the North Pole, on the side of the moon that faces us. So the first thing here is the regolith adherence characterization, or the RAC. Essentially, it's some tests they're going to do to determine how sticky the lunar dust is to various objects. The next one here is the next generation lunar retroreflectors. So I think that's pretty self-explanatory, but they're putting newer versions of the retroreflectors that were put back in the Apollo days. New versions of those will be going up. The LEXI, which is the Lunar Environmental Heliospheric X-ray Imager. That one is going to capture images of the interaction of the Earth's magnetosphere with the flow of charged particles from the sun, also known as solar wind. So that's going to study that interaction from the moon. We also have the RAD-PC, which is going to demonstrate radiation-tolerant computing technology. This is due to the moon's lack of atmosphere. Really makes electronics on the moon susceptible to radiation. So they're testing different ways to protect those items from radiation. The Lunar Magnetotelluric. Then we have the LMS, is designed to characterize the structure and composition of the moon's mantle by studying electric and magnetic fields. The Lunar Instrumentation for Subsurface Thermal Exploration, or LISTER, is designed to measure heat flow from the interior of the moon. This one's going to dig down about 10 feet under the regolith and test the soil for different thermal properties. Pretty cool. The Lunar Planet Vac is designed to acquire lunar regolith, so that thing is going to just collect some of the regolith and study it, and also put some aside for potential future vehicles to return them to Earth. Stereo cameras for lunar plume surface studies. So this one is going to be capturing images and video from underneath the lander as it's landing to study the plume effects that the thrusters have on the surface of the moon. Then we have the electrodynamic dust shields, which will generate non-uniform electric fields using very high voltage on multiple electrodes. This traveling field in turn carries away the particles and has potential applications in thermal radiators, spacesuit fabrics, visors, camera lenses, solar panels, and many other technologies. And finally, we have the Lunar GNSS receiver experiment, which is based on GPS. So essentially, this thing they're hoping is going to be able to discern the first GPS signals at lunar distances. So that is something to watch out for. Again, stop on by 2 a.m. Sunday morning. That is the 2nd. And join us for the watch party. Bring your energy drinks, bring whatever you got to do to stay awake, and let's watch this thing land on the moon.